Alright, I wanted to review point-slope form equation of a line with you. I know that many of you are very familiar with y equals mx plus b. That is the slope-intercept form of a line, where m is the slope, b is the y-intercept. And so in Algebra 1, they really drilled that into your head. It was nice and easy for you to graph with. But for point-slope, that's going to be very useful as you continue on in mathematics. So both are equations of lines. But I don't think you're quite as familiar with point-slope as you are slope-intercept, so this video is going to focus on that. So recall what slope is. Slope is your rise over your run. And once again, many students in Algebra 1 are drilled into their head, this is the equation for slope, y2 minus y1 over x2 minus x1. So for point-slope form equation of a line, if you've got this memorized, you can quickly come up with the point-slope form equation. If I get y2 minus y1 by itself in this, what do I need to do to get rid of this denominator? Well, just like with any fraction, let's suppose we had, I don't know, x over 3 equals 5. How do we get x by itself? Well, you multiply both sides by the denominator. And when you do that, you get x equals 15. So that's what we're going to do down here. To get y2 minus y1 by itself, we're going to multiply both sides by the denominator, like that. So when I multiply this side by the denominator, this cancels out, and then I end up with m times x2 minus x1 is equal to y2 minus y1. And so that looks like this, and that's pretty much our point-slope form. We typically don't write the x's and the m on the left side, but you could, it doesn't really hurt. So normally we write it like this, and usually we drop the y2, y1, the x2, and the x1 because it just becomes simply y minus some number equals the slope times x minus some number. So this is how a textbook typically points it out, where x1 and y1 here are one known point on the line, m is the known slope, and then x and y right here can be any other point that's on that line. So try this one out on your paper, at your desk, or at home, wherever you're watching this. So it says a line passes through -3 and 6, that's our known point, and it has a slope of -5, that's our known slope. What is the equation of the line? So I'll let you pause it, try it out. Alright, so we've got, oops, went backwards there. We have y2 minus y1 equals m times x2 minus x1. That's our point-slope form equation. Substitute in the values we know. So positive 6 goes in right here, -3 goes in over here for our x1, and then -5 goes in for our slope. And so here's where we need to clean it up a little bit. When you see minus negatives, we need to change it to plus positives. And that's really the only spot we see that one. So our equation becomes, we can drop the 2's actually. I didn't do that ahead of time, but I'll rewrite it out here. So we get y minus 6 is equal to -5 x plus 3. And so this sometimes is a little bit odd for students because they're thinking, you know, y should be by itself or x should be by itself something, and it just looks strange. But keep in mind, as I come to this and I look at this, I recognize and I say, hey, what did I put in right here for y1 that gives me -6? I must have put in a positive 6. What I put in right here to give me a positive 3? I must have put in a -3 for x. So I know that one point on the line is -3, 6. What's the slope? Well, the slope is whatever's listed right here, which is -5. And if I wanted to graph this, unlike y equals mx plus b, where you have to start at the y-intercept and then use the slope to find the second point, I can start anywhere where this given point is, so -3, 6 in this case, and then use the slope. I'd go down 5 and over 1 and find my second point. We'll see that graphed out here in a minute. So next, a line passes through these this one point and has this slope. What is an equation in point-slope form of a line? So pause the video, try that one out. And so what you should have gotten here was y minus this point right here. So y minus a negative 4 is the same thing as y plus 4. And that's equal to the slope times x minus the x coordinate. There's our slope-intercept form of that line. So the key thing is when we substitute in, make sure that you change all minus negatives to plus positives. All minus zeros, you just kind of get rid of that 0. And always make sure you put your slope in there. Now, if we're looking at graphing, what is the graph of the equation y minus 1 is equal to 2/3 times x minus 2? So when I'm looking at this is all the book's directions here, but this is just how I do it. What did I put in for 1 in that equation to get minus 1 here? Well, I must have just put in a positive 1. And what did I put in for x to get a minus 2? Well, I must have put in a positive 2. So that tells me I can start at 0.21 and then use my slope of 2/3 to finish the rest of the graph. So let's take a look at that. You start at 2,1 right there. Our step 2 is right here. So using the slope, you go up 2/3. Boom, there's you find your second point. You only need 2 points to draw a line, so after that you can draw a line through the 2 points. Notice we didn't need to use the y-intercept. Why is this helpful? Well, what if we use this in y equals mx plus b? Let's convert this line right here, it's in point slope form, into our slope-intercept form, also known as y equals mx plus b. So how do we do that? Well, we first distribute the 2/3. So what we'd get is 2/3 x minus 4/3 is equal to y minus 1. So we need to add 1 to both sides. So add 1 to the left side, you get y. Add 1 to the right side, well, negative 4/3 plus 3/3 is what we're doing here. And so adding that, we're going to get negative 1/3. And so our y-intercept's negative 1/3, or negative 0.3 repeating. And you can even see it right here going through that. So if I had to graph this by hand, it would be a little inaccurate if I started at negative 1/3 and then try to go up 2 from it, and then over 3 from it. I might be somewhere over in here. So let's see here, up 1, 2, over 1, 2, 3. And I think I'd be a little bit off because it's hard to judge where 1/3 is. But since our y-intercept is not an integer, it makes it a little bit harder to graph it using y equals mx plus b. But putting it in slope-intercept form, not slope-intercept form, point-slope form, makes it pretty easy to graph because we get our whole numbers here that we can slice our line through. Try out this equation, try graphing this. So pause the video, try it out. So we want to know what point does it go through. Well, I know I must have put in a positive 4. We're just taking opposite values here. And I must have put in a negative 7 for my y2 value. And then I know my slope is negative 4/5. So I first graph 4, negative 7. I might have to move my graph up to do that. So over 4, down 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to use the slope of negative 4 over 5. Well, I can't go down 4 anymore, so I'm going to go up 4 instead. 1, 2, 3, 4, and then to the left 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right here. And if you want to do it again, you can. So up 4 over 1, 2, 3, 4, 5. It might make it a little bit easier to draw a line through. If you got 3 points, you can perhaps line it up straighter. And so there's my line. So sometimes they'll ask you to write the equation of a line and they won't tell you the slope. They'll tell you 2 points instead. So you need to know how to do that as well. So here we're given that a line passes through 1, 4 and negative 1, 1, and it wants to know the point slope form of that line. So one of the things I need to do is figure out what is the slope. So I'm going to call this x1, y1, x2, y2. I'm going to put it into the equation for slope. And then substituting in, I got y2 minus y1, so I've got 1 minus 4. x2 minus x1, so I got negative 1 minus 1. And so I end up with negative 3 over negative 2, which equals positive 3 over 2. So that's my slope. And so when I go to put it into this equation, y minus something is equal to my slope, which I know is 3/2, minus, and times x minus something. All I got to do now is pick one of these 2 points, either 1, 4 or negative 1, 1. I'm going to pick 1, 4. So I'm going to put 4 right here, 1 right there, and I'm done. That's a correct answer. However, you could have used the other point there. You could have used y minus 1 is equal to 3/2 times x minus a negative 1. Well, x minus a negative 1 is the same thing as x plus 1. So as I'm grading these, if you had a problem like this, both of these are on my answer key ready to give it to you correct. Okay? And if for some reason you found some other point on the line, that would be fine too. There's an infinite amount of points, so there's a lot of different ways you can present these answers. But just to make it easy on me, please use one of these points. It makes it easier on you too. Okay? So that's another way that you can see that type of problem. Hopefully that's enough for review for you. If you need more help though, I'm always more than happy to help you. I can make more videos. You can see me during class, after class. I'm going to give you an assignment on this so you get plenty of practice. Okay? Thanks for watching and keep working hard.